Okay, last time we talked about fractional expressions. Okay, today we're going to talk about fractional equations. Fractional equations just means equations with, anybody want to guess? Yeah, coefficient being fractions. Now it's a little bit, we did talk about expression with fractional coefficients last time, but this one's going to be a little bit different because you're going to have some variables on the bottom of these fractions, okay? Last time we just had numbers. But the idea is the same. What do we do when we're dealing with equations with fractions? We multiply both sides by, everybody? LCD. So it's going to be the same even if you have some variables on the denominators. Does that make sense? So please keep that in mind. It's the same exact thing we've been doing before. Okay, here we go. So write this down. An equation with a variable in the denominator of one or more terms is called fractional equation. So as I mentioned before, last time we talked about equations with fractional coefficients. We didn't have any variables in the denominators. Now you're going to have variables in the denominators. And as we said before, we're going to multiply both sides by the LCD. Okay. How do we solve this? Always, whenever you have equations with fractions, you have denominators. It's easy to get rid of these denominators. Just multiply both sides by the LCD. Okay. So who remembers? There's one thing that you have to be mindful of. Whenever you're dealing with equations with variables in the denominator, what do you have to be mindful of? Anybody remember? It starts with R. And a lot of you, Vanya, restrictions. That's what happens, right? Whenever you have variables in the denominators, right? Because you have variables in the denominators, the values of those variables could make the denominator go to 0. Do you want 0 in the denominators? No. So write this down. This is one of you must be mindful of restrictions. So whenever you have equations with variables in the denominators, you must be mindful of these restrictions. And we'll talk about what this means as we do some problems. That's the only difference, okay? All the other equations, we had fractional coefficients. We didn't have any variables. Now that we have variables in the denominators, you have to be mindful of restrictions. Okay? Let's look at example 1. Here's an equation with now variables on the variable. We have one variable here. Variable on the denominator, 3 over t minus 1 over 2 equals to 1 over 10. Okay. So look at this equation. 3 over t minus 12 equals to 1 over 10, right? Thomas, what should we do here in this case?
You're going to have to get the LCD.
Exactly right. We're going to multiply both sides by the LCD. So what is the LCD? Look at all the denominators. Doesn't matter which sides they are in, right? Look at all the denominators of both sides. T, 2, and 10. What will be the LCD for this fraction? Okay? Any of you? How about Olive? Oh, you want to... Okay, so you could, like before, we could make the fraction on the left to have a common denominators and add them together. But remember, that's what we do when we have expressions. Right now, we have an equation. What did we say? Whenever you have an equation with fractions, what do we multiply both sides by? LCD. What's the LCD for t, 2, and 10? 2t? Okay, if you do 2t, the left side will be fine, right? Things will cancel out. But what about on the right side? Will 2 cancel out with 10? I mean, in other words, will 10 go into 2? Because we want to get rid of the denominator. So it would not be 2t, would it? 10t is correct. So you're going to multiply both sides by 10t. Go ahead, everybody try and see what you get, okay? And go ahead and tell me what we get next when you do this, okay? Okay, here we go. Who can tell me what we get here? Justin, can you tell us?
30t over t.
Right. And what happens with the t's? They cancel out. Right. So let me see if I wrote it out like that. So just write down exactly 30t over t over what? I mean minus 10t over 2, and on the right side we get
10t over 10.
exactly 10t over 10. And then when you simplify, Justin, what do we get? Why do we multiply both sides by this so that all the denominators will go away, right? Do they go away, all of them?
Yes.
Yeah. On the left, what do you get when you simplify?
30 minus 5.
5 or 5t?
Oh, 5t.
Uh-huh.
Equals t.
Exactly right. You see how this whole equation, right? At first, it looks very kind of complicated. But once you multiply both sides by the LCD, we get an equation that we know how to solve easily, right? All we have to do is what, class? Add both sides by 5t, and we get what? 6t equals 2? Yeah. And then don't you get 5 as the answer? Now, we talked about this. So we got the answer as equals to 5, right? There's the answer. How many people got 5 as the answer? Very straightforward. Do you see how it's very similar to what you did before with the equation with fractional coefficient? But turns out, do you remember the restriction? What was the restriction for this? T can't be what? Can't be 0. Because if t was 0, our original equation is not even defined, right? Look at the first term. It'll be 3 over 0, right? So why do we have to be mindful of this restriction? Because sometimes, at the end, guess what? What if you solve this whole thing and t equal to 0? Can you use that as your solution? No. Why not? Because that was your restriction. Does that make sense? So it does happen that your answer comes out to be one of your restriction. This time there was only one restriction, right? One restriction. But there could be more than one, right? Depending on how many variables you have on the denominator and so forth. So therefore you got to be mindful of these restrictions. So you have to check at the end whether or not the answer you got, right? Your answer should not be one of your restrictions. If it was, you cannot use that as your answer. Does that make sense? So we'll get to one of those later. So if this t came out to be 0, right, then you will say there is no solution for this because t was your restriction. Does that make sense? Sometimes you get more than one answer, right? So then you get, instead of getting 2 answers, you get 1. Does that make sense? And not only that, there's one other thing you gotta, even though multiplying both sides by the LCD, right, makes it really easy. It turns out whenever you multiply both sides by a variable, right, when the LCD contains a variable, you may be adding more solution than this original equation. So you have to always check the answer at the end. So write this down. Must check the answer when solving fractional equation because we're multiplying both sides by some variable. Okay, that could be adding more solution than it originally had. Okay, so therefore, every time you do these, you have to always check. Okay. So, how do we check and see if this is a correct answer? Yes, Alvin. Plug it back into the original equation, and when we do that, so let's see. I plugged it in and multiply both sides by 10 again. Because you get 3 over 5, because our original expression was 3 over x, wasn't it? Minus half was equal to 10, so it does come out to 1, doesn't it? So you have to always plug it in and check, okay? And even if you forgot your restriction, right, as you plug it in, you will know that, oh, it makes my denominator go to 0, so I can use that one. You know what I mean? But it's good. It'll save your time rather than just checking your restriction. If you see one of your answers is your restriction, you can't use it. So we'll do something like that in a minute, but right now, that's what you gotta do. So whenever you multiply both sides by some variable, right, you gotta check the answer. Because you could be introducing more solutions to it. When you multiply both sides by a number, do you have to check the answer necessarily? No, that doesn't add any more solutions. But when you multiply both sides by some variables, it does. So you gotta check it always, okay? So I wrote down the original equation here for you. You gotta always plug into your original equation, right? Not the one that you simplify, because that's the one that you multiply both sides by some number and a variable, right? So that's not an equivalent equation. When you multiply both sides by a number, that's fine, but not with some variables in it. Okay, it doesn't become equivalent equation. Okay, so that's why you have to plug into your original equation, and this time it turns out to work. So 5 was your answer. Okay. All right, let's move on to the next one here. So take a look at example 2. Gets a little more interesting. N plus 1 over n plus 2 minus 10 over n squared minus 4 equals to 0 is your equation. And of course, this equation has, a bunch of denominators. We have to find the LCD, don't we? We have to multiply both sides by the LCD. So do you guys remember how to find the LCD for these denominators, n plus 2 and n squared minus 4?
Yes.
What do we have to do first in order to find the LCD for these denominators that contains variable? Who remembers? We did this with some of these things before. How about, I think we dealt with something like this. How about Nicole? Do you remember?
You have to factor all.
Yes, you had to factor all the denominators first, That's how you could figure out your LCD, correct? So look at the n plus 2, the first denominator. Can we factor that more? No, that's already simplified. You can't. I mean, that's already, you can't really do much with that. What about max? N squared minus 4. Could we factor that? How? Yeah, it's a difference of 2 squared. By this time, you should all know, right away. So what does that become? How about, Stephanie, can you tell me what to write? With n squared minus 4, it should be what?
10 over n plus 2 times n.
You got it. Okay, so there you go. So first step, must factor the denominators if you want to get the LCD, right? So there you go. Now that we have these denominators as n plus 2, n minus 2, n plus 2, what is going to be my LCD here in this problem? How about, Arvin, what do you think our LCD will be? N minus 2 and n plus 2 will be your LCD, isn't that right? Because the first fraction has n plus 2 as its denominator. The other one contains it. So just n plus 2 times n minus 2 will do it, correct? Let's look at the restrictions. Let's be mindful of our restrictions. What numbers can we not use as our solutions? So this one's sort of easy to see. Serena, which numbers can we not use as our solution? Look at the denominators, right? Think about the restriction. What would the restriction of n plus 2 be?
So the first one, negative 2.
Yeah, if your answer comes out to negative 2, could we use that as our solution? No. Do we even need to check that one?
No.
No, because it makes the denominator go to 0. We don't even need to check. There's another one though. Do you see another one, Sabrina?
Yeah, positive 2.
Positive 2, because here you have n minus 2 over here, right? And this one, n plus 2, is still negative 2, so still. So you're right. The n cannot equal to 2 and n cannot equal to negative 2. I would write this on the top, right, just to check at the end, right? Because sometimes when you cancel things out, right, you don't see, what you had on the denominators. So I will write that on top, kind of reminding myself, I cannot have n equal to 2 or negative 2, right, as our solution. And our LCD is n minus 2 times n plus 2, okay? So let's multiply both sides by ID. LCD, n plus 2 times n minus 2. That would guarantee us to have, right, all the denominators go away, correct? How many terms do you have on the left side, by the way? Show me with your fingers. How many terms do we have on the left side? Okay, how many terms do we have on the right side? Okay, if there are 2 terms on the left, there's only 1 term, right? It's just 0, right? So you're going to multiply both sides by ID, LCD. How many times do you have to multiply the LCD to the left side?
2 times.
2 times, because how many terms do you have?
2.
2. And some of you mentioned, let's just change it to addition. That's a good idea. I'm going to change it to addition like this. Is that okay? So I don't make silly mistakes. Go ahead, everybody try. Okay, everybody go ahead and try. And what is 0 times anything, class? 0. Okay, so can you just not put anything? Can you put nothing on the right side?
No.
You gotta put 0. 0 is a number, okay? You can't just put nothing. Nothing and 0 is different, okay? Because then it becomes an expression. It does not, right? You have to keep it as an equation, don't you? All right, go ahead. So make sure you distribute this to the left side. There are 2 terms on the left. When you distribute this, you gotta multiply it twice, correct? Go ahead, everybody try. And you should not have any denominators on the bottom. All right, who can tell me what we get on the left side when first of all, let's multiply n plus 2 times n minus 2 with the first fraction. Somebody tell me what we get with that. How about Kyle? With the n plus 2's cancel out, right? So what do we get? Let's not do that yet. Just tell me what we get. The n plus 2's cancel out, we just get n minus 2 times? Exactly. Don't we get n minus 2 times n plus 1 on the left? That's the first term? Okay, good. And of course, when you have that, we're going to multiply them together in a minute. Okay. Then, what about next here? Zareth, what would we get? What would you get when you distribute this LCD with the second fraction?
You get negative n plus 2 times n minus 2.
Yeah, and things cancel out. What do you just get? What do you get when you simplify that?
Negative 10.
Negative 10. That's all you get, which is plus negative 10, right? Is that okay? All right, and equals to, what's 0 times anything? 0. Just simply. So do you see how simple this is? So what do we do with these two binomial times binomial? What do we do with these two? We multiply them out, right? So you got to multiply n times n times negative. So you get n squared minus plus n minus 2n minus 2 minus 10 still equals to 0. Right? And when you simplify, how many people got a trinomial? N squared minus n minus 12. Raise your hand. If you didn't, go ahead and fix it, because this is what you should have gotten. Most of you did get it. Go ahead, help each other. You should have gotten n squared minus n minus 12 equals to 0. Okay, go ahead. Everybody fix it if you didn't get that.
No.
Because if you didn't get this, that means you made a silly mistake here. Class, is this our answer? No. This is what we get. That whole, you look at your original equation. The one that looks very kind of tough, as soon as we multiply both sides by the LCD and simplify, it just becomes a nice equation like this. Right? And we know how to solve this, don't we?
Yes.
Okay. How do we solve? Now, is this a linear equation?
No.
No, it's not a linear equation. So every time you get an equation that is not linear, we use zero product property. Remember, we have to make it equal to 0, which is already equal to 0, which is nice.
Yeah.
What do we do with the left side then? We factor. Do you guys remember factoring this trinomial? And this is really nice because, look, what is the coefficient of the leading term? It's 1. Right? If it's 1, it's really easy to factor, isn't that right? Remember, we got to put them vertically. It's got to be n plus something times n plus something, right? What is the number we need? Okay, go ahead, everybody factor. I'll wait for you. Okay, so let's take a look at this. What do we need? We know we have to have n and n here. What do we need to fill in so that when you multiply vertically, you get 12, and when you do this cross, you get negative n here? Who thinks they know? How about Brandon? What did you get? How do we factor this? What do we need here? N minus 4. So you need n plus negative 4 times. Does this work, class? Okay, let's see. N times n, you get n squared, right? What about negative 4 times negative 3? Is that negative 12? Good. So that's good to, okay, but, you know, most important thing is the middle term. What is n times 3? 3n. What is n times negative 4?
Negative 4.
So when you add 2, you get negative n.
No. Yes.
Yes, so that checks.
Yes.
So we get this, right? What does this mean? We factor this left side. So this remember zero product property. We got a product that equals to 0. This is the key in terms of how we could figure out the answer. Cool. What is this telling us? What is this telling us? N must be either, there are two possible solutions for this, right? 4 or negative 3, because look, if n is, remember we do a little side work, right? This is only true if what? N minus 4 equals to 0, true if n minus, or n plus 3 equals 0, because if one of them is 0, the whole thing is 0, right? So there are two possible solutions.
Wait. It's not wrong.
Okay. So Noah, what do we get? N has to be equal to what? Either 4 or negative 3, right?
Yeah.
Now, what do we have to check? Can we just write these as our solution?
No.
We have to check and see whether they're what? Restriction? Are any of these our restriction? Let's go back up. We wrote it down in the very, no, none of them. Because restrictions were 2 and negative 2. Are these 2 or negative 2?
No.
No, so then can we say now, finally, that these are our solution, negative 3 and 4?
Yeah.
No. You have to check, because we multiply both sides by some variables, right? We could have introduced more solution to this equation, right? So we gotta check, and how do we check? Everybody check. Plug it in, okay, to the original equation. See if negative 3 and negative 4 works. Okay, go ahead, everybody check. Did you all get it? Both of them checks out, don't they? Right? They all work, both of these. So we're now ready to say what? The answers are negative 3 and negative 4. Is that okay, guys?
Yeah.
So here, this is where I checked it. Okay, so there's the answer.
It's frozen.
Okay.
Sorry.
Here we go. Okay? Any question?
No. No.
Okay, good. Let's move on to example 3 then. Let's do example 3. I'm gonna have you try to do this yourself now. We have 2 over x squared minus x minus 2 over x minus 1 equals to 1. Okay? So go ahead and do this one yourself. If you get stuck, I'll help you, and you could ask your group also. So go ahead, everybody try. Okay. I'll wait. Okay, let's see how far you are. But at least, were you able to get the LCD this way? By factoring out all the denominators? Okay, so you got x times x minus 1. And then, of course, when you factor the x, and then you got x minus 1. What is your LCD? How about Ala? What's our LCD here? X times x minus 1. How many terms do you have on the left side, class?
2.
How many terms do you have on the right side, class?
1.
So when you distribute x times x minus 1 to the left side, how many times do you multiply? Since there are 2 terms? Twice. Okay. So, okay, this is what we'll be doing. By the way, what are your restrictions? X can't be? How many? Okay, first of all, show me with your fingers. How many restrictions will you get in this problem? A lot of you have 1, 2. Okay, there are actually 2, aren't there?
Wait.
X can't be what, first of all? 0. If X was 0, the whole thing is 0. And what about this? X can't be 1. And this one too. X can't, not negative 1.
Oh, sorry.
X can't be 1. Think about it. When will X minus 1 be 0? We add 1 to both sides. X can't be 1, right? So there are 2 restrictions that you got to think about. Okay, so there are 2 restrictions like this, and LCD was what we just said. All right, somebody tell me what we get on the left side when we distribute this LCD. Elisa, over here. What do you think? 2 minus 2x equals to?
1.
Is it 1? Or you gotta multiply both sides by the LCD. So 1 times the LCD is simply x times x minus 1, right? Okay, be careful. This time it wasn't 0. Okay? So, right, it just becomes 2 minus, right? Because the whole thing cancels out. Isn't that nice? That's why we like this LCD, right? The whole denominators cancel out. We just get 2. Minus, the x minus 1s cancel out, but you still have x, so 2 times x. And then on the right side, you're multiplying both sides by the LCD, so don't just write 1. It'll be x times x minus 1. Correct?
Correct.
Okay, go ahead and now keep going. Okay, I'll wait. Alright, some of you are having a bit difficulty, so let's do this together. If you already are almost done solving, that's good. Okay, let's look at this together for now. Alright, Indira, what do we do on the right side then?
You add 2x.
Add 2x to both sides? Not yet. Don't you have to multiply this out so that you get all the like terms together and so forth? So you gotta multiply x times x minus 1, right? What do we get when we do that?
Plus x squared minus
Correct. Very good. Now we're gonna gather your like term. Does that make sense? Let's gather all our like terms. Do we have any x squared? Like term with x squares? No. Alright, so we do have x's. So let's add 2x to both sides and yeah, subtract. So that when we do that, I get this. Now we want to make it equal to 0, don't we? Because we get an equation that is not linear, right? So subtract 2 from both sides. So this is what you should have gotten. 0 is equal to x squared plus x minus 2. How many people got this?
That makes sense.
Okay. Do you see how to do it now? A lot of you didn't get this. Okay. Make sure this is what you get. Now, of course, we try to factor this trinomial, correct? And this is easy to factor, again, because our leading coefficient is 1, is that right? So, who could tell me what this factors to? Amy. Okay, you didn't? That means you did something wrong. Because this is what you should have gotten as a trinomial. Did you get x squared minus x minus 2 or no?
Yeah, no, I just shorted it out and then
Factor out of negative 2.
on the other side, on the south point where this I didn't factor out the x and x position. I just factored out.
Yeah, if you factor out a 2, it doesn't really help you too much on the left side.
But you end up with x minus.
Yeah, you gotta get this trinomial. I'll give you more time. Go ahead. Everybody, make sure you get this trinomial. Because if you didn't, then you did something wrong. Okay. I see what some of you did here. You guys factor out a negative 2 from the left side. Is that what you meant? And then divided both sides by x minus 2 and so forth like this, right? I wouldn't suggest you do that yet. Because if you do this, you may be losing one of your solutions. Okay, because if you divide both sides by some variable, you'll be losing some of your solution. So don't do it that way. Just gather all the like terms and then get a trinomial this way. Is that okay? Because I just saw your work. I see what you mean. If you do it this way, then you'll be losing one of your solutions. Okay? Jonathan is right. The solution comes out to be negative 2 and 1 because when you factor this trinomial, who could tell me what this trinomial becomes? Ray, were you able to factor this trinomial?
Oh yeah.
What do we get?
X plus 2 times x minus 1.
Correct. X plus 2 times x minus 1. That's how you factor that, right? And there are 2 solutions for this. What are the 2 solutions? This is only true if, using the zero product property, x plus 2 equals 2, class? 0, or x minus 1 equals 2? 0. So what are the 2 solutions you get? X could be negative 2 or 1. Does that make sense? Right? This is true if what? True if x plus 2 equals to 0 or x minus 1 equals to 0. You add negative 2 to both sides and then 1 to both sides. That's what you get. Now, do we have the answer solution right now? No. We got 2 solutions here. We gotta check and see if one of these were our restrictions. We had two restrictions before, right? What were they? 0 and 1. Uh-oh. Can we use x equals to 1 here? No. So then we only get -2. We gotta drop this because this was your restriction, right? This is our restriction. We drop this because it's our what? Restriction, right? Remember? This is one of our restriction. So, what's our solution? -2. But are we sure? For now, are we sure that this is our solution, or do we have to check? We must check, don't we? Okay, go ahead and everybody check. Plug in -2 to the equation and see if it comes out to be true. Go ahead. So when you check, did you all plug into the original equation here? You get the no?
No, just kidding, sorry.
So then you get 3 over 3 equals 1. It does work out, right? How many people got that? Raise your hand. Okay, good. It does work out. Now, let me tell you why you don't want to divide both sides by variables on the both, right? Variables with factors with variables. So imagine that we got this. 0 is equal to x plus 2 times x minus 1, right?
We did get that.
Yeah, let's divide both sides by x minus 1 both sides.
Okay.
Okay, what do we get? 0 is equal to x plus. Now, if you could do that, why not divide both sides by x plus 2 again? We get 0 equal to 1. You could keep dividing both sides by the terms with variables, right? If it equals 0, you lose all your solutions. Does that make sense? So you don't want to divide both sides by, right, expression that has variables in them, and the factors with the variables in them. Does that make sense?
Yes.
Does that answer your question?
No.
Okay. Okay, here's example 4. This one is an interesting one. This will be our last one. Take a look at this. This is sort of interesting. You get 3y minus 6 over y minus 2 equals to 3. Okay? Three y minus 6 over y minus 2 equals 3. We're going to multiply both sides by the LCD here. Okay? Which is y minus 2. Correct? Because 3 is really 3 over 1. It's got a denominator of 1.
Wait, it's 1.
Okay, so we're going to multiply both sides by y minus 2, okay? Okay, some of you noticed that I could factor the top, right, and cancel things out, right?
I already finished.
So, Sabrina, what do we get then?
You factor it out, so you get 3y minus 2, and then you cancel out the y minus 2 from the numerator and the denominator. So then if you get 3, you'll see which is an identity.
Okay, so what do you think your answer is?
3 equals 3.
Well, yeah, you get 3 equals 3. Okay, hold on. So no matter how you do it, you could either multiply both sides by the LCD, or cancel out your. You could factor the numerator, right? I don't know if I did it though. Okay.
It's frozen.
Okay. So you could do this, and you get 3 equals to 3, don't you? Right? Or you get add 6 to both sides. You get left side basically equals to the right side. Right? What kind of equation is this? An identity equation, right? So whenever you have an identity equation, what is your solution? In other words, if the left side equals to the right side, some of you did it this way. 3 times y minus 2 over y minus 2 equals to 3. You cancel out those y minus 2's, even though I told you don't cancel those out yet. But anyway, so you get 3 equals to 3. That's another way of doing it. But the one on the left is better, okay? Because you want to be, right, dividing things by the factors that contains variables, because you lose your solution. Anyway, what's your solution? Alvin? How many people say all real numbers? Okay. Yeah, most of the time when you get an identity equation, it's all real numbers. But this time it's not all real numbers. Not everything will work. Who sees which value won't work? Jonathan?
It's all real numbers except y equals 2.
Exactly, because here's your restriction, right? Look at the original equation. You got y minus 2 on the bottom. So can y be 2? No. So what do you write as your solution? You're right, it's all real numbers except 2. That's what you need to write down. So when you get an equation with variables in the denominators, right? Even though you get even though the left side will get equals to the right side, sometimes you have to write down your exception. So everything will work except 2, because when y is equal to 2, right, it will make it undefined. Does that make sense?
Yes.
Okay, any questions? No. Okay, so you guys have to be a little bit careful when you have variables in the denominators, okay, with the equations with variables in the denominators. Okay. Good.